This is the third video on properties of logs, and in this video we'll cover the last property of logs, and then we'll focus on putting them together, which is where the real fun begins. So this last property of logs looks like this. If you have log base b of m to the nth power, this n right here, the exponent, can be moved down in front and it would become the coefficient of log base b of m. This is specifically the property that I did not want you using on your exponentials quiz about a month or so ago because I had not taught it to you. And it's one of the ways that you can use to solve exponential equations, but it's usually not the best way. The best way and the most efficient way is the way that I showed you. This particular property is needed in certain kinds of exponential equations, which we did not look at that particular kind. And so as long as you're not looking at that kind, this is really not the best way to do it. It's the way photomath might have you do it, but it's not the best way, which is why I did not show it to you earlier. It does come in handy. Of course, there are some problems where you need to see it. So, or need to use it. So as with the last two lessons, we're going to do 3 examples where we expand it. Now this one, it's hard to make an argument like which side is actually like the longer side, but I figure like an exponent is smaller than a coefficient, like is physically. So technically like this way over here is like expanded. And then this way is the collapse way. So for the first bank of examples, we're going to have log, and these are our expand examples right here. I don't know why my E's changed. That's kind of weird. My E in expand is totally different from my E in examples. I don't have an explanation for that. And my upstairs neighbors are crashing over the ceiling. So if you hear a thumping sound, probably that's not getting picked up, but all right. So the first example is log base 8 of 2 squared. And if you're going to expand this, you would take the exponent of 2, and that exponent of 2 is going to be moved down in front of that log. So you'd have 2 times log base 8 of 2. Second example is log of 3 to the x. Now this is where you would use it in solving an exponential equation. So if you have like 3 to the x equals something, one of the things you can do is you can take the logarithm and then engage this, and it's going to take that x that is currently trapped in the exponent and move it down so it is no longer in the exponent, and then you could use your calculator to do log of 3. So log of 3 to the x could be written as x log 3. Notice too how I'm saying it out loud. It's important that the way that you're saying it in your head matches what you're writing and that you're using the right vocabulary even when you're just thinking about it in your head. And the last one, this is kind of an interesting one. If you just have the natural log of 9, well, the natural log of 9 is equal to 3 squared. And now when I write it this way, you see that there's an exponent, and that exponent can be moved down to the front. That process that I just did there is called simplifying a logarithm. And it's the idea that you get the smallest argument possible for your logarithm. So if you have anything that could be written as an exponent, you're going to write it as that exponent and then bring the exponent part down and leave the base as the argument of the logarithm. It's something that maybe you would have to do like in a college algebra class, like my college algebra students would be expected to simplify their logs. Usually when you're first learning how to do this, that's not something that you would be asked to do, but that is what that process is. And now let's go in the other direction. So let's do some collapse examples. And the first one I have of this is if we had 4 times log of 2. So if you're collapsing it, then the coefficient, that is the number multiplying the log, so this is 4 times the log of 2. Again, make sure that you're saying it in your head right. This is multiplication right there. Okay, notice where I'm pointing. That's a times sign, 4 times. This is not multiplication. I'm going to pause and let that sink in and say it again. This is multiplication, 4 times the log. This is not multiplication. Now, to collapse this, the coefficient can be moved over into the position of the exponent. So this would be log of 2 to the 4th. Now, sometimes you'll leave it like that. 2 to the 4th is 16, so that's not a big deal to do the exponent out, but if the number was going to be something much larger than 16, then probably you would leave it as an exponent just for practical reasons. All right, next one is y natural log of x. And again, your coefficient, even if your coefficient is a y, can be moved into the position of the exponent. And so that would be natural log of x to the y. Here, I tend to, most of the time, I do like a cursive L when I'm doing the natural logarithm, but I obviously don't always do my L's like that because my other logs are done with a printed L. And here I did it with the natural log. That is not an I. And I was just grading some late homework from earlier in the quarter, and folks are writing a big capital letter I there, which just kind of tells me that you weren't really listening to the lesson if you were writing it with an I, because I'm usually very, very clear about that. Now, this next one is going to give us a little sneak peek at where the problems go from here. And so in this one, we have 3 times log base 2 of, and then inside the argument of the log, we have multiplication. We have 4n. And so what we're seeing here is a combining of this particular property with the first property we studied, which was if the argument is a product. Now, we're not going to go there right at this moment, but we're going to take that 3 and we're going to move that 3 into the position of the exponent. And then, so then I don't do it. Let me try that one more time. There we go. And just, I'm going to do this in a different color, I think, just as like just to point this out, that you can use your properties of exponents here. So you could do 4n all to the 3rd power, or you could write that as 4 to the 3rd power, n to the 3rd power. That's using a property of exponents, and that can come in pretty useful. And that's it for the 3rd property. So on your paper that you've been keeping with your classwork, you've got the previous assignment, which was that quotient work. So that's on your paper somewhere. Maybe it's on the front. Maybe you've gone over to the back. And I'm going to give you 8 problems. And as always, we're going to do the expand on the left and the collapse on the right. And as always, I'm going to read them out loud just in case there's something that you're not sure what you're looking at. Number 17 is log base 3 of 4 to the n. 18 is log base 2 of 25. 19 is the natural log of 3 squared. 20 is the natural log of x to the 5th. 21 is x times log 5. 22 is 3 times log base 4 of 6. 23, I hope I said that right. 23 is 1/2 of log 16. I'm going to put a little asterisk by this one because not because it's hard. It's all stuff that we've covered. But when you move it, you'll be able to simplify it one more step. So make sure that you do that. And number 24 is 4 natural log y. And that completes our 3rd lesson on properties of logs.